In this problem, we're going to be graphing a couple of square root functions and looking at their key characteristics. So part A, we're given f of x equals the square root of 12 minus 4x. We're asked to find the domain, the horizontal intercept, and the vertical intercept, and then also to provide a graph. Now I'm going to go ahead and put that graph in first so that I know what I'm working with. So I want to clear out my y equals, go to second, and then above the x squared is the square root 12, subtract 4x, and then go to that arrow key to end my radical. And I'm going to graph this, make sure I'm on a standard window, zoom 6. So I can see the shape here of this graph, and I'm going to go ahead and draw that down here, and then as I find things, I'm going to label them on the graph. So it looks like I'm starting at x equals 3, and it looks like I'm going through somewhere between 3 and 4, about right there. And let's see if I can draw a decent graph here. There we go. That's all right. All right, so we need to find these ordered pairs, find the domain, stuff like that. So for the domain, we want what's under the radical to be greater than or equal to 0. So 12 minus 4x must be greater than or equal to 0. So I could solve this in a bunch of different ways. The easiest way to do this is to add 4x to both sides. So that gives me 12 greater than or equal to 4x. Then if I divide both sides by 4, I get 3 is greater than or equal to x. And sometimes it's awkward to look at inequalities written in this direction. So I can rewrite that. If 3 is greater than or equal to x, that's the same thing as saying x is less than or equal to 3. So we didn't switch the inequality, we switched everything, and so we haven't changed anything. So x less than or equal to 3 is my domain. I can see that by the graph here, all the x values less than or equal to 3 are being used to generate this graph. I want to write my domain in interval notation, so that's going to be negative infinity up to and including 3, so I have a square bracket here. So remember that negative infinity is this way. And so this is 3, 0. That's my horizontal intercept. I can see it from the graph, but how I would find it algebraically is to set 12 minus 4x equal to 0. Again, I'm going to add 4x to both sides. 12 equals 4x. Divide both sides by 4, and I get x equals 3. So the horizontal intercept is 3, 0. Now the vertical intercept, this point right here, I'm going to evaluate f of 0 because my ordered pair here is 0, comma something. So I'm going to take that 0 and replace x with 0 inside the function. So I get the square root of 12 as a result. And if I compute that on my calculator, I'm not going to do those steps. I think you know how to do that. But I'm going to get 3.46. So there is my vertical intercept. Let's take a look at part B. G of x is the square root of 2x minus 5. So you might wonder how this graph is going to look a little bit different from the first one. Notice the x term in the first one is second. The x term in the second one is first. So let's go to y equals, clear out, second, and then working with the square root, 2x minus 5. Press the arrow key, and then graph. I know I already have a standard window because of what we did before. So now, let me go ahead and replicate that graph. I'm going to move my vertical axis over a little bit. And so it looks like, it's kind of hard to see exactly, it looks like it's starting somewhere here, and then going up and to the right. So let's find all of our pieces. So to find the domain, we want what's under the radical, 2x minus 5, to be greater than or equal to 0. That means that 2x is greater than or equal to 5. If I divide both sides by 2, I get x is greater than or equal to 5 halves. But let's write that as a decimal. 5 divided by 2 is 2.5. I want to write that as an interval. My domain starts at 2.5 and goes to infinity, and I can see that on the graph here because remember, infinity is that way. So this is going to be a starting value of 2.5, 0. That's also my horizontal intercept, but I can verify that algebraically by setting 2x minus 5 to 0, add 5 to both sides, divide by 2. I'm going to get the same thing I did over here. So you might be noticing a pattern that for these square root functions that intersect the x-axis, that start at the x-axis, I should say, the starting value of the domain is going to be the horizontal intercept. Now let's see what happens with the vertical intercept. You can see by the graph that there isn't one, but let's go ahead and see how that would work if I tried to do the computation. So I would want to evaluate g of 0, plug that in to my function, 2 times 0 minus 5 equals square root of negative 5, which is not a real number. Therefore, the vertical intercept does not exist, and we can see that that's verified with the shape of our graph.